In the name of Allah, the most beneficent and merciful. Dear students, Assalamu alaikum. I'm here, Muhammad Tajamal Khan, lecturer in botany, University of Education, Lahore. Today we proceed our fifth lecture of elective course of microbiology. The course code of this elective course is BOTN 4128. Our today's topic is related. So our today lecture is comprise of one of the most important item. Without being, microbiology is nothing, and that is microscope. Today in this lecture we discuss detailed parts of simple or compound microscope. As you know, microscope is the fundamental component of microbiology. Most of the microorganisms can't be seen with naked eye. So for this purpose, we should emphasize the usage of microscope, and being the science student, one should know the usage of microbiology and the fundamental or the major parts of microscope. So in this lecture we reveal different parts of microscope. So here we start. So here we have the view of a microscope, and in this pictorial view you see the different parts or different components of microscope, and that combine to form this legendary item as you observed in this slide. Later on we discuss each and every part in detail in this lecture. So the major component or the major things that is necessary for the composition of microscope is light, lens, and a specimen. So these three things are the necessary requisition of microscope for the study of microorganisms. So here we begin the detailed parts of simple and compound microscope. Before we going to different parts of simple and compound microscope, one must know what is a microscope. For this, here we have a question: what is it? So the first thing that is the term compounds. So this term refers to the microscope having more than one lens. Then when we utilize more than one lens, then we call it as a compound microscope. So the term light refers to the method by which light transmits the image into your eye. And what is microscope? So microscope is the combination of two words. One is micro, meaning small, the other one is scope, meaning view. So we have two types of microscope here. I already indicated there. One is simple microscope, the other one is compound microscope. So in simple microscope we use a single lens, while in compound microscope we use a set of lens or lens system. So this is the main discrimination between simple and compound microscope. Either the principle of both microscope are same. So here we have two microscope, this one and this one. So the first one, this microscope, is different from this microscope because these two microscope mainly different in the source of light. Here you already see that one use a mirror. So here this microscope use light through mirror, or the source of light is mirror, and in this microscope it use illuminator. So light source is illuminator here in this microscope. So we have two source for light in microscope. One is mirror and the other one is illuminator. So mirror captures the light from sun and illuminator produce light through electricity. So in a compound light microscope with more than one lens and its own light source. So the parts of the modern microscope and the path light take through it are shown in the figure later on in this lecture. So a compound microscope with a single eyepiece, and eyepiece is also called as ocular. We said that it is a monocular. With two eyepiece, is said to be a binocular, and trinocular has a third eyepiece tube that can be used by another person simultaneously or by a camera. So the trinocular option is more expensive than other two types. So actually, for oversimplicity, we divide a compound microscope into three main parts. One is mechanical part, second one is magnifying part, and the last one is illuminating part. We discuss all these parts one by one. So here in this slide I indicated you by a red underline. These underlined parts are the mechanical parts of microscope. Suppose here we have a inclination joint. This is the mechanical part. Then we have a pillar. Here this is a pillar. This one is a pillar. This one is a pillar. So this is also a mechanical part. Then we have a base. This base is also a mechanical part. Then we have an arm or neck. Here this one is arm or neck. So this one is also a mechanical part. Then we have a stage here. This one is a stage, or this one is a stage. This is the mechanical part. Then we have a stage clips here. This is the stage clips. These are it also a mechanical part. Then we have a body tube. This one is the body tube here. This one is the body tube. That is also a mechanical part. Then we have draw tube. Here we have a draw tube. This one is a draw tube. So here this one is a draw tube. I use the PowerPoint. So this one is a so this is also a mechanical part. After this we have a resolving nose. This is also a mechanical part. In addition to this we have a dust shield here and here. This one is a dust shield. After this we have a coarse adjustment knob. This one is a coarse adjustment knob. Similarly here this is a coarse adjustment knob, and this one is a fine adjustment knob. So coarse adjustment knob and the fine adjustment knob both are mechanical part. So in addition to this we have a condenser here. This one is a condenser adjustment knob, and above the condenser adjustment knob here we have a iris diaphragm. So this is a diaphragm. So these all are part that are indicated by a red line. These are all mechanical parts of microscope. So here in this slide I indicated you the illuminating parts of microscope. So here we have a mirror, or illuminated, this is the illuminating part. In addition to this we have this is a condenser. This is also the illuminating part, illuminating power of part of microscope. In addition to this, here we have a diaphragm. Previously we discussed the diaphragm lever. So here we have a diaphragm. And this diaphragm increase or decrease the intensity of light, so it is also called as iris. Iris diaphragm. So these are the illuminating parts of microscope. In addition to this we have magnifying parts. This is called as eyepiece. Eyepiece, and eyepiece is also called as ocular. So it's the ocular lens also, though this eyepiece or ocular is the magnifying part of microscope. In addition to this we have a objective or objective lens. This objective lens is also the part of our magnifying part of microscope. So now here we discuss one by one different parts of a microscope. First of all, we discuss about the mechanical parts of microscope. So here, first of all, we discuss base. This is a base, as you seen in this slide. So base, what are the common function, or what is the credibility of the base? Bottommost portion that support the entire microscope or lower microscope. So this is the most important part on which the whole apparatus for microscope stand. The next is pillar. As you shown, this is a pillar, and here we have a pillar. So pillar, the part above the base, and that supports the other part. The next is inclination joints. Here we have a inclination joint, as you see here. So the inclination joint actually provide a movement of microscope to and fro movement. So it restricted the left and right movement, but it allows the to and fro movement that is possible through inclination joint. So allows for tilting of the microscope for convenience of the user. So the next is arm or neck. Here we have an arm or neck. This one, here we have an arm or neck. So this is the curved part which is held while carrying the microscope. So by using the arm, we carry the microscope to either place. So by using this arm, actually from this one can grip the microscope by hand. The other one is stage. Here we have a stage, as you shown here. So stage is a plate-like structure or a disc on which we place a specimen. So here we have it is a platform where object to be examined is placed, or slide of specimen is placed to be observed. The next is we have a stage clips. Here we have a clips. These are the clips. So actually these grips actually grip the slide of specimen. So it restricts the movement of slide on a stage. So here secure the specimen to the stage. Next one is body tube. Here we have a body tube. Here we have a body tube. So this body tube attached to the arm and bears the lenses. So the lenses are present in this body tube, and the vision through lenses is possible through a body tube. The next or the last one is the draw tube. So basically a draw tube holds the upper lens or ocular or eyepiece. So it is a cylindrical structure on the top of the body tube that holds the ocular lens. So after this we have some parts. Here we have a revolving or rotating nose piece. Here this is indicated here. This is this. So actually these are the structures where we hold the lens or objective. So basically this is a rotating or revolving nose piece, and 3 to 4 lens we can connect here as an objective. So rotating disc where the objective lens are attached. After this we have a dust shield. So here we have a dust shield. Here lies atop of nose piece and keep dust from settling on the object. So actually dust shield prevent the objective from dust. The next is coarse adjustment knob. Here we have a coarse adjustment knob. So this one is a coarse adjustment knob. It's geared to the body tube, which elevates or lower when rotated, bring the object into an approximate focus. So it shows upward and downward movement by rotating this knob, so we can focus with the clear focus on our specimen that is placed on stage. So we slightly move this knob for adjustment. The next one is a fine adjustment. Here we have a fine adjustment. So the smaller knob for delicate focusing, bring the object into a perfect focus. So when we use fine adjustment when we have a blur view of the specimen, so by using fine adjustment we can make a view clear. After this we have a condenser adjustment of knob. Here we have a condenser adjustment of knob. Actually it condenses the light, so we can use light as we require. The next is iris diaphragm lever. One thing more, it elevates and lowers the condenser to regulate the intensity of light. Similarly, the other is iris diaphragm lever. Here we have this one. So lever in front of the condenser, and which is moved horizontally to open or close the diaphragm. So diaphragm is also used to regulate the light intensity. Now we're looking towards the illuminating parts of the microscope. So here we have a mirror. This one is a mirror or any light source. We also call it as illuminator. So this one is a mirror. So located beneath the stage and has a concave and plane surfaces to gather and direct light in order to illuminate the object. So the main purpose of this mirror or illuminator or electric bulb is to focus light on specimen. Similarly, we use in some microscope there is electric lamp. So a built-in illuminator beneath the stage that may be used if sunlight is not preferred or is not available. So the next is iris diaphragm. Here we have iris diaphragm, as you observed here. Regulates the amount of light necessary to obtain a clear view of the object. The other one is condenser, which is also an illuminating part of the microscope. A set of lenses. Here we have this one is a condenser. A set of lenses between the mirror and the stage so that it concentrates light rays on the specimen. So now we have a focus on magnifying parts of microscope. So basically it consists of two lenses. One is ocular and eyepiece, the other one is objective. So first of all we have ocular or eyepiece. So it is another set of lens found on the top of the body tube which function to further magnify the image produced by the objective. So here we have an objective lens and here we have an eyepiece. So ocular is used to view the specimen after the magnification by objective lens. So it usually ranges from 5x to 15x in power. So the next one is objective one. So here it again repeats the same, so leave it. Metal cylinder attached below the nose piece and contains specially ground and polished lenses. So we have various lenses that we use as objective. First of all we have a LPO, it's mean low power objective. So it gives the lowest magnification, usually near about 10x. Then we have a HPO, high power objective. Here it gives higher magnification, usually from 14x to 43x. And then we have OIO, oil immersion objective. It gives the highest magnification, usually 97 to 100x, and it used wet either with cedarwood oil or synthetic oil. So for using oil immersion objective, we must put a drop of immersion oil on a slide or that contain a specimen. So these all about related to magnifying parts of microscope. So here we again have the components of microscope, but with the larger pictorial view. Here we have an eyepiece, as you observed in this slide, as we already studied. This one is a eyepiece. This one is an eyepiece. So eyepiece is the lens through which the viewer looks to see the specimen. Below here, as you clearly observe the stage clips. Here, stage clips. These are the stage clips, and these are the objectives. As you know, the objective lenses are the one of the most important part of microscope, and they are closest to the specimen. And standard microscope has 3 to 4 objective lenses, range from 4x to 100x. And in addition to this, the stage clips are metallic clips that held the slide in a place. Here we have an arm or neck, as I already told you in the previous slides. So the arms connects the body tube to the base of the microscope. And similarly, we have a base. This one is base. So the base supports the microscope, and it's where illuminator. So the illuminator is the light source for microscope. Here we have a illuminator. This pictorial view enhance the beauty of different components of microscope. So you clearly see the electric lamp or illuminator here. So a compound light microscope use a low voltage bulb as an illuminator. The next is stage. Here we have a stage. This one is a stage, and that is used to place the slide. So stage is a platform, is a flat platform where the slide is placed. So again, here we have a nose piece, a revolving nose piece. So a nose piece is a rotating structure that holds the objective lenses, and the viewer spins the nose pins to select different objective lenses here. In addition to this, we have a very special structure that we didn't discuss earlier. Here we have a aperture. So aperture, what is the function of aperture? Aperture is the middle of stage that allows the light from the illuminator to reach to the specimen. So the specimen is placed here on this aperture, and so the light or illuminator, so the light from illuminator passes through this aperture and transmit from specimen. The next one is condenser. So here we have a very clear diagram of condenser and a diaphragm. This one is a diaphragm. So diaphragm is a 5-hole disc placed under the stage. Each hole is of different diameter, so it regulates the intensity of light. By turning it, you can vary the amount of light passing through the stage opening. So now here we have some technical terms that related to a microscope. Here we have a magnification. So magnification actually is the enlargement of a specimen. So we can say that the compounds microscope have up to 6 interchangeable objective lenses that have different powers of magnification or power of enlargement. So the total magnification of a light microscope is calculated by multiplying the magnifying power of the objective lens, so the lens used to view your specimen, or by magnifying power of the ocular lens, the lens nearest your eye. So the power of magnification, or the formula of power of magnification, is here. Simply magnifying power of the objective multiplied to the magnifying power of the ocular, then we attain power of magnification. So the one thing that is very necessary I had here, when there is a high magnification, so there is a need of greater amount of light to see the specimen very clearly. So another technical term that related to a microscope is the resolution. So good resolution, or the resolving power of the microscope, is necessary to see the valuable detail comprised in an image. So what is the resolution? So resolution actually is a resolving power, or is the ability to measure the separation of images that are close together. So the most important part of microscope is the objective, which must produce a very clear image, and not just a magnified one. So the resolution is extremely important, and so resolution is the ability of a lens to separate or distinguish between small objects that are very close together. So here we have a light path. How does light travel through a microscope? Here you observed in this diagram, or in this figure, the light. So here light is first emitted by the light source. This is the light source, and is directed by the condenser lens on the specimen. So through this condenser lens, it falls on a specimen. Here we have a specimen. After the light from specimen then passes through the objective lens. Here we have this specimen, and then light passes through this objective. After this, further light rays pass to a projector lens. So here we have a projector lens, and lights pass through this, which reserve their direction so that when the image reaches the eye, it will not appear upside down. So actually by using this light, actually this lens convert or invert the image. So not all microscope have a projector lens, so the viewer may be seeing a reverse image. In these cases, when the side light is moved, it will appear to be moving in opposite direction to the viewer, and this will happen due to the projector lens. So the light rays then travel to the ocular lens. From this, light enter into a ocular lens. This is often a 10x magnification lens, meaning it magnifies the magnified image an additional 10 times. So from that, the image that is received by the projector lens, after viewing from ocular lens, it magnified this projector lens image 10 times more. So the image is then projected into the eye. So here we have a very simplified presentation from light source to one eye through an eyepiece. So this yellow color indicate a path of light within a microscope. So from here we have a source of light that produce light, and from this illuminator this light enters into a condenser. Then this condenser condense the lights as you observe there, and after transmit from the specimen, it enter to a body tube where lens or where the objective lens are present. So these objective lens then make a view, and it passes through this body tube, and from the eyepiece one can view the specimen from his eye. So here we have a very good slide in which we observe the total magnification and the view that we attain or obtain from microscope on different magnifications. So here we have a lens of 40x, and then we have a 10x, and when we want to get magnification we multiply this 4x to 10x, then we obtain 14x. So here this diagram indicate that at 14x we observe such type of specimen from microscope. Similarly, here we have a 10x of objective lens and 10x of eyepiece. Then we multiply both for magnification, we obtained 10x. This is view at 10x. Similarly, here we have a objective of 14x and eyepiece of 10x. The magnification power is 400x, and this view is obtained at 4x. So there is a clear discrimination against different magnification of microscope. So here again we have a typical values of a microscope with 10x ocular lens, and the objective lens having different magnification powers indicated in this slide. So here we have the operating procedure of microscope. Simply there are 5 steps that is used to operate the microscope. Here first of all, light enters the microscope from a source in the base and often passes through a blue filter, which filters out the long wavelength of light, leaving the shorter wavelength and improving resolution. The second one is that it then goes through a condenser which converts the light beam so that they pass through the specimen. After this, the iris diaphragm controls the amount of light that passes through the specimen and into the objective lens. After this, the objective lens magnifying the image before it passes through the body tube to the ocular lens in the eyepiece. The ocular lens further magnified the image. So a mechanical stage allows precise control of moving the slide, which is especially useful in the study of microbes. So the focusing mechanism consists of 2 knobs. One, a coarse adjustment knob, which changes the distance between the objective lens and the specimen fairly rapidly, and the other one, our second one, is the fine adjustment knob, which changes the distance very slowly. So here we have some uses or benefits of compound microscope. So one of the biggest benefits of owning a light microscope is its simplicity and its convenience. The second is a compound light microscope is relatively small. Therefore, it is very easy to use and simple to store, and it comes with its own light source. So this is the very big benefit of compound microscope in place of mirror. However, because of their multiple lenses, compound light microscope are able to reveal a great amount of detail in sample. And the other benefit of compound microscope is that even an inexpensive one can reveal an incredible view of the world that would be impossible to explore with the naked eye. So here we have the references that proved to be very fruitful in the making of this presentation. So this is all about for this lecture. I hope you get very beneficial information related to microscope in this lecture. So stay safe and healthy. Allah Hafiz.